Okay, who can read first?
I'll read since Tyrone doesn't want to read.
Okay,
I'll
go
steal
ahead.
his. Okay.
Go.
A quadrilateral is a polygon with 4 sides. A parallelogram is a quadrilateral that has 2 pairs of parallel sides.
Perfect.
Do I read the rest?
No, that doesn't really matter.
Okay.
Don't worry about that. Okay, so that is the definition of a parallelogram. It has 2 pairs of parallel sides. So in this little parallelogram I've got here, I'm going to name it A, B, C, D. BC is parallel to AD, and AB is parallel to DC. Okay, so that's what a parallelogram is, but then on top of that, we have some theorems that we're going to be talking about today. There's going to be 5 theorems, and each theorem we're going to do a proof. So it's going to go, we're going to learn the theorem, do the proof, do the theorem, do the proof, back and forth like that. So here's my first theorem. My first theorem states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are the opposite sides parallel, not only are they parallel, they're also going to be congruent. So BC is congruent to AD, and AB is congruent to DC. Huh, interesting. I wonder why that is. Actually, you know what? I just updated Zoom. Apparently there was some update and I did it, so maybe that's why my camera looks better. All right, Janelle's, yes, you can go to the bathroom. Everybody else, make sure you have this written down. So here's our theorem. If a quadrilateral is a parallelogram, then the opposite sides are congruent. Basically, yes, the parallel sides are going to be congruent to each other. So can I move on, or does anyone still need a moment to write down? Okay. So let's do our first proof. We're going to prove what we just wrote down. We're going to prove that opposite sides of a parallelogram are congruent. So this one has a little bit of information. We're kind of filling in some blanks. Who would like to start us off with the easy one? What's first?
Given.
Given. Good. ABCD is a parallelogram. I always, for some reason, I just want to say parallel. It's a parallelogram, and that is given. Okay, then it says to draw DB. So notice how they kind of drew this dotted line. I'm just going to highlight it in blue. They drew DB. DB is called the diagonal. And they drew it in because when you draw in that diagonal, what do you create? What do I do by making that line?
A diagonal line.
Yes, but what does that kind of split my parallelogram into?
Two sides.
Two
Like
sides.
Two triangles.
There we go, 2 triangles. And we already know a lot about triangles, right? We already know, we have a lot of theorems, we have a lot of proofs that we've done in the past with triangles. So we can use that information to figure some stuff out. So let's look at number 3. So number 3 now says AB is parallel to DC and AD is parallel to BC. How do I know that those pairs of sides are parallel to each other?
Because of those little arrows.
Okay, yes, because of those little arrows, but why am I able to draw those little arrows? Why did the textbook draw them in?
They're parallel.
But how do I know that? Take a look at, all I know so far is that I have what type of shape?
A quadrilateral?
Not just a quadrilateral, I have I have a
yeah.
parallelogram. And what do I know
Okay.
about parallelograms?
Dalen.
No, what do I know? What's the only thing I know about what's in the definition of a parallelogram? We just wrote it down.
Opposite sides are congruent.
The opposite sides are congruent. Dang it,
Stop,
Carla.
you're cheating.
No, 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 no.
Oh.
This is what I'm trying to prove right now. This is a theorem. Theorems are things that we prove. But what is something before I prove it? What is the only thing I know about a parallelogram?
The opposite sides of each shape are equal.
Like I said,
Okay,
that's what we're trying. That's what we're trying to prove. So I can't use that yet. But Tyrone said it in the chat. The only thing I know is the definition so far. And the definition says
Equal.
a parallelogram is a quadrilateral that has two pairs of parallel sides. That's all I know. I know they're parallel. I haven't proven yet that they're equal, but I do know that they are parallel based on the definition of parallelogram. So be careful. You can't use what you're trying to prove in order to prove what you're trying to prove. You can't say the sky is blue because the sky is blue. Okay, you got to use other reasons to get to that point. Okay, then number 3, ADB, let me highlight. ADB is congruent to CBD. ADB congruent to ADB is congruent to CBD. I think they messed up. Oh no, yeah. Okay, this one. Sorry. Okay, so those two green ones. And then it says ABD, so this one up here, is congruent to CDB. Okay, how do I know that? How can I be certain that those angles are congruent to each other?
There are alternate interior angles.
There, yeah, you got it. Alternate interior angle theorem. Okay, good. Does anyone want me to explain how that works? Why that's alternate interior? It's very similar to what we just did in the bell ringer. Okay, finally, DB is congruent to DB. Good, reflexive. Property. Okay, and now we have to think of the next statement. But the next statement has to do with ASA. So what can I prove using ASA?
Oh, that angle CDB is congruent. Wait, I don't know which side to do it on. Basically, angle D, and then the reflexive side, so side DB, other angle.
Right, so I have two angles and their included side. So what is congruent to what? If I'm using ASA, what am I making congruent? What two things am I?
Oh, the triangles.
The two triangles are congruent, yeah. So
Not the
triangle, go ahead and name them for me.
Can
to
they
make
be
sure
in
they
any
match up.
order?
They have to match up. So remember, whatever you choose for your first triangle has to match the second one.
So like if I start with B, for the next triangle, I have to start with D?
Yes.
Okay, triangle BDC is congruent to triangle DBA.
Good.
Okay.
Good. All right. So now I've got my two triangles. I know that they are congruent, and I think I saw the next answer up above somewhere. What is my final reason that I can say? Because now I can say that AB is congruent to CD. So now I can say that AB is congruent to CD. And I see Tyrone's got it. And I can also say that I'm running out of colors, that CB is congruent to AD. And that is CPCTC. Good job. All right, how do we feel about that? Kind of getting back into it, right?
I don't like proofs, and I still don't like them. So, well,
I know, and I'm
not
not,
wrong.
Anxiety.
I'm not gonna force you to like them, but by the end of this year, you will know how to do them whether you like them or not. That is what it is. All right. Another theorem. You do not need to rewrite the definitions. We already wrote those, but I just have them on the slide. Here's my next theorem. This theorem states, can I have a volunteer read it for me, actually? Go ahead, Tara.
A quadrilateral is a polygon with 4 sides. A parallelogram is a
We already,
quadrilateral.
I meant just the theorem because we already wrote down the definitions.
Oh, if a quadrilateral is a parallelogram, then its opposite angles are congruent.
Okay, so now we're trying to see how this is true, that the opposite angles are congruent. So that would mean that angle A is congruent to angle C, and angle B is congruent to angle D. So this is what we're trying to prove next.
Miss, oh, never mind. I don't know if I can tell you this.
Does that have to
But
do with
in
the
one
test?
of the questions on the EOC, it talked about parallel lines. No, but
Nice.
it was just one of the answer choices, not like it wasn't the answer though, obviously,
But you
I
knew
was like,
already.
oh, yeah.
Nice. Sometimes, see, they go hand in hand sometimes, geometry and algebra. All right, so here we go. Similar, we start off with a similar thing. I mean, we always start off with the same thing.
Could you go back to the theory?
Yeah, of course, go ahead. Let me know when I can go, okay?
Yeah, you could go now.
Awesome. Okay, so we always start off with given, of course. And why am I drawing DB again?
Big angle.
To help me see what? The triangles. Now the reason for that, and let's go back to this one really quick. This is just something that we'll see a couple of times. So just through any 2 points, there is exactly one line. It's just basically saying, since you have 2 points, you are able to draw a line between them if you want to. So through any 2 points, there is a line. That's our reason. Okay. Then it's saying AB is parallel to DC and AD is parallel to BC. What do we already know that's going to be?
Definition of a parallelogram?
Parallel.
Yeah.
God damn, I tried to steal that answer.
Too slow. Definition of a parallelogram. So far, things are looking very similar, right? Now, alternate interior angles theorem. What can I prove using the alternate interior angles theorem?
Wouldn't it be angle D and B?
So can you name them a little bit more specifically? Because D can refer to like the top half of D or the bottom half of D.
Oh, okay. Can I do CDB or BDC?
So CDB, that would be this one. And what is that congruent to?
ABD.
ABD, good. That one up here. Would anyone else, can somebody else give me the other 2 angles that are congruent because of alternate interior angles? What's the other pair?
Fine, I'll do one.
Go ahead.
DAB and BCD.
Okay, be careful. Those are the ones we're trying. So you're talking about this one and this one?
Yeah.
Those are the ones we're trying to prove. We actually can't get to that quite yet. That's going to be like the last step. So not those, but then what's the only ones left over?
The top and bottom of each one. I don't know.
No, A, B, D. Wait, no, that's already done. It's A, D, wait, this
Yeah,
is
yeah.
that third.
Yeah. A,
A, D, B.
D, B. There you go. And
Okay, I know C. Goddamn, I don't know how to goddamn read letters.
it's okay. It's okay. Go ahead. What's the other one? You got this.
B, C, D.
B, C, D.
Yes, B, C, D.
Careful, Alejandro. That's this one.
Oh, again, I screwed up. I don't know.
You got this. Come on. You got this.
I'm cringing at myself currently right now.
You got
What
this.
I
You
did-
got one last try. Go.
CBD. That's what I meant to say.
CBD. There you go. I know. This is like, it's really.
I am cringing at myself, and I know for a fact that if I ever see the video, I will cringe so goddamn hard.
Just don't watch this part. Just skip from this part. Okay. So here we are. So we've got these angles. We know that they're alternate interior angles because I have parallel lines. Next up, what can I use the reflexive property for? Oh, Tyrone's already in there. Good. DB is congruent to DB. Beautiful. Reflexive. Okay, next up, what can I prove using ASA?
This the part I said. DAB and BCD.
Okay, however, and you're correct, but don't skip a step because before you can prove that the angles are congruent, you have to prove that the triangles are congruent. So right now, all we know is that the triangles are congruent. So that would be triangle DAB. And how do I match up? What would the other triangle be? If I wrote DAB.
BCD.
Good, BCD. But now that I know that the triangles are congruent, now I'm able to finally put my what I'm trying to prove, what I've been trying to prove all along, which is that angle A is congruent to angle C. And what is my reason? What is my reason? I know that they're congruent now. I didn't know before, but I know it now. And why is that?
Reflective.
It's not reflective.
No, well, not reflective, but the angles. That's all I could say. The reason why angles are congruent is because angles are congruent.
Angles, well, okay, what did we prove in the previous step? In the previous step, we proved that the triangles are congruent. Since I already know that both triangles are congruent, I know that the angles of those triangles are congruent. Using what? There's this, we've seen it before. We actually used it in the previous one. Yeah, CPCTC. I want to review CPCTC really quickly because I think there's some confusion around it. So basically, first, if you prove that two triangles are congruent, if you do that first and then you want to prove that two parts of a triangle are congruent, so if you're going in this direction, the first thing you know is that the triangles are congruent, then you can prove that a specific part of those two triangles are congruent. That's CPCTC. Oops, C. So first you got to know that the triangles are congruent, then you can go and say, okay, angle A is congruent to angle C. That's CPCTC. Do you guys remember how there's also the converse of CPCTC? So the converse of CPCTC goes the other way around. If you know that all the parts of a triangle are congruent, if you've proven that every single part of triangle number 1 is congruent to every single part of triangle number 2, if you're going this way now, that's when we use the converse of CPCTC. Okay, so one direction is CPCTC, the other way would be the converse of CPCTC. So I just wanted to clear that up. Do I have questions on that?
No.
Okay. Okay, third theorem, we're getting there. There's 4 of them, so we'll probably breeze through this today. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So it's a little bit different. Somebody tell me the 2 letters that I should connect to make a diagonal.
B and D.
B and D. So here's one diagonal. What's my other diagonal? AC, good. So what is this saying? This is saying that the diagonals bisect each other. What does it mean to bisect? Cut in half. Very nice. So these 2 diagonals cut each other in half, which means that this point here would be that would have a name. What would the name be? Good, Jalen. The midpoint.
Miss, no, you shouldn't just accept them saying one part of the word. Because what if we're gonna say mid segment or midpoint?
You're right. You're right. I should not accept their laziness.
Yes. Yeah, Jalen.
Okay, so if that's the midpoint, then somebody give me 2, and let's name this midpoint M. Somebody give me 2 segments that are congruent to each other. What can I count as congruent?
BM and MD.
BM would be congruent to MD. Good. And what else?
AM and MC or CM.
Good. AM is congruent to MC. Okay, so that's what our theorem states, but we're going to go ahead and prove it now. So we're going to go ahead and see how we can get to that point. But I'll give you guys about a couple more seconds to copy this down if you haven't done so already. Okay. That's fine, Perla. All right, now we've got a whole proof. We're going to fill in everything, but I did give you guys a little word bank, okay? So what I want you guys to do, I want you guys to try this completely on your own first. So draw a table of statements and reasons in your sheet of paper to practice this on your own. This is very good practice to do because on a test, most of the time the tests are actually easier than this. So it's good to take it to the extreme, do the hardest type of problem so that you're prepared for whatever might be on the test. So I'll start with about 3 minutes. Use the word bank to help yourself out and fill in the easy stuff first. There's a lot that you can fill in right off the bat. Yeah, Tyrone, we're doing it. You're doing it on your own first. So take a moment. Yeah, the order does matter, but I will say that there might be more than one way. Okay, so as long as whichever way that you pick to do it makes sense, then you're good. But we'll see what happens. I'm curious to see what you guys think. Oh, Perla. Perla, 6 sugar packets? Girl, you'll be
Yeah,
up
I
all.
like it sweet.
No. I like my coffee just black coffee. But I really feel that too. I'll show you guys. We might finish early, and if we do, I'm going to show you something. I'll keep it a surprise though. Yes, Janelle's, I like black coffee. No sugar, no milk, no nothing. Just give me that straight caffeine, nothing else. I love boba. You guys have no idea. And let me tell you, Miami does not have good boba. I used to go to school in New York City, and New York City has like really, really good boba places. You guys don't even know what good boba tastes like. Okay.
Yes, I don't like doing proofs. Can I just skip this one and can I just watch?
No.
How Billy puts that face, he says, I watch. That's what I'm gonna do. And then I'm
Nope.
gonna fall asleep with
You
my
are going to
tablet.
do this right along with everybody else. We all have to suffer.
No.
Okay, so let's start with the obvious. What's first?
Given.
Given, but what is given?
ABCD is a parallelogram. Thank you, Tyrone, for the answer. Now I don't have to do work.
Okay. ABCD is a parallelogram. Awesome. Is there something that we see in the answer choices that I could use next? If all I know is that I have a parallelogram,
Maybe the definition of a parallelogram.
that would make sense to me. What happened, Pearl? I thought you were leaving us.
Oh, I'm sorry. I can't leave my classmates alone, especially since they're all quiet.
They would not survive without you. I don't know, got a lot of
You know, I'm humble. So
poor,
I would.
unfortunate souls. Okay, well, what can I prove using the definition of a parallelogram? What do I know? Because I have a parallelogram, what can I say?
They have. Oh yeah, never mind. Emily beat me to it.
AB, good. AB is parallel to DC.
And AB to CB. I mean DA. What? Wait. I just confused myself. I'm sorry.
It's okay, it's okay. Okay, cool. Good. Moving right along. Remember, at the end of the day, what am I trying to prove? Which, by the way, we can put that in so that we remember our end goal. I'm trying to prove that AE is congruent to CE and BE is congruent to DE. Where can I go next?
We can put CPCTC for that one.
CPCTC for which one?
The last.
For the very
one,
last one? That's a
maybe.
possibility, but we don't know that for sure. So you can't really do that because You just have to make sure that you're not skipping steps. You never know. Take a look at let the words on the side help you out.
I
Okay,
think it's opposite. Oh,
that's okay. What I was saying to Jalen before is that the order matters to an extent. You might do one thing before another as long as it makes sense from step to step. So what Jalen is saying, he wants to use the alternate interior angles theorem. That would make sense as long as the next step after that continues to make sense. Do you guys get what I mean? Like, you don't want to jump from one step to another without it making sense. Okay, so right now, how do I know that I can use the alternate interior angles theorem? Like, that does make sense to go next. Why? What did I just use in the previous step? Or what did I just prove in the previous step?
parallelogram.
That I have a parallelogram and that I have
Parallel. Never mind. I don't know what I'm saying.
yeah, that you have a parallelogram and that parallelogram has parallel sides. And since I have parallel sides, I know that the alternate interior angles theorem has to do with parallel sides, right? Don't forget that whole thing has to do with transversals, right? So I've got a transversal here. When I extend everything, you can see it a little bit more clearly. I've got one transversal, but then I also have another one, don't I? I've got another transversal. So there's a lot of sides to choose from, or angles to choose from that I can prove are congruent. So I'm going to start by just writing alternate interior angles theorem. But now we're going to have to think about what exactly am I going to prove using the alternate interior angles theorem? The opposite thing at the top. So can you be more specific? Which angles are alternate interior angles?
CDB and ABD.
C, DB, and A, yes. So this and this. No, this and
Oh,
this, sorry. So sorry. Okay, good. So let me write that down. And you know what? Hold on, let me think about this for a second. Yeah, no. Okay, I'll keep going. So angle BDC is congruent to angle, what did you say? ABD, right? Okay, good. What else can I prove using, because look it comes up twice. What else can I prove using the alternate interior angles theorem?
BDA and DBC are congruent.
Where, hold on, BDA, okay. So this one and this one?
Yeah.
That's not wrong. They are congruent. However, what am I trying to prove at the end of the day?
Oh, never mind.
Let's pick a different set of angles that are congruent. Because you're not wrong. but that's not really going to help me to prove that they are congruent. We are going to use alternate interior angles again, yes. We are going to use it again, but the question is, which two angles am I choosing? A and C. Okay, now you're on the right track. You're on the right track. So which part of A and which part of C? Because again, A and C are split by that diagonal. So let me see. Janelle's is saying B, C, E. So this one, hold on. B, C, E, and D, A, E. Again, they are congruent, but those are not the ones I'm looking for. What about D, A, E? No, that's not helpful either.
What about B A E and wait, I just confused myself.
So this one
Yeah.
and
B C E
okay.
or
These
A?
two.
Oh.
Yes, those are the ones I want. And you'll see why in the very next step. If you're a little confused, like why did I have to choose 4 different angles till we got to the right one? It'll all make a little more sense in the next step. So this was, what is this? What was it? DCA is congruent to BAC. Okay. Now I'm gonna do something really quickly because I just realized I believe these two were just supposed to go in the same step. Wait, what did I do? Okay, hold on. Yeah, I believe they were meant to be in the same spot just to save space because otherwise, oh my goodness, okay. I'm trying, guys. Because otherwise it won't have enough boxes for me. There we go. Okay. So yeah, I think they were supposed to go in the same space, but that doesn't matter too much. Now take a look at what we have. We have 2 angles that we know are congruent between kind of like that top triangle and like that little bottom triangle. Do we see that?
Yes.
Okay, so I'm kind of looking at this top triangle and this bottom triangle. So look at the answer choices. What can help me to prove that those two, because I'm almost there, I have 2 angles. What's left to prove that they're both congruent?
Wait, can you repeat that? I couldn't process that in my brain.
So right now I'm going to kind of split them up. I have these 2 triangles, right? D, E, C, and A, E, B. What do I know so far? I know D is congruent to what?
B.
B. I know A is congruent to?
Wait.
Jalen's got it, C. That's all I know so far. What do I have to know? What else must I prove in order to prove that they're congruent to each other?
Vertical angles.
Okay, so I saw you said the same thing as Jalen.
Oh, never mind.
But what would that be if I had 3 angles?
Oh, that's not a congruence theorem, so we need a side.
Right, that's AAA. And remember, AAA is fake news. That does not work. We can't use it.
So we need to prove that side DC is congruent to side AB.
There you go. We need to prove that this is congruent to that. And looking at my answer choices, what can help me to prove that?
The first one,
Yeah. DC is congruent to AB. And that's the first one. Opposite sides of parallelograms are congruent. Okay, we're almost there. We're almost there. So I have almost all the information I need in order to prove my point. If I know that these two are congruent, now what am I proving next based on what I have? Let me cross this one out. Okay. Based on what I have, what must come next?
shouldn't we need one? Oh, never mind. We already have our two angles and we have our side. Oh, ASA.
Yeah, we have ASA. We do have ASA. So what am I proving with ASA? What do you use ASA for?
To prove that triangles are congruent.
So what are my two triangles called? I only hear Perla. Perla, don't say anything else. Can I have somebody else? Name those two triangles that we know are congruent? Which two triangles do I know are congruent? C.
D
Oh, go for it, Daniel.
DEC and AEB. Wait, no,
Good.
BEA.
BEA, yeah. Perfect. Okay. And since I know that those two triangles are congruent, we know, okay, I can use CPCTC to finally say that what we've been looking for all along, that AE is congruent to CE, and that DE is congruent to BE. So in other words, after all that work, I can finally prove that the diagonals bisect each other, which is what we've been trying to say all along. So this one was definitely hard, guys. This was not an easy proof. The most important thing about this one was that, take a look at what we started with. Our parallelogram that we started with was cut into 4 different triangles, but also like 2 triangles, if you kind of ignore the green line and only look at the blue line, there were 2 triangles that way. And if you only look at the green line and ignore the blue line, there were 2 more triangles that way. So there were like 6 different triangles to choose from, and we had to figure out which 2 triangles will help you to prove what you're trying to prove. Does that make sense? I know that you guys were a little bit confused throughout, so I need to make sure that we understand. What questions do you guys have? Any questions? Step 4 was the important step because that's where we had to choose which angles to make congruent to each other. Okay. I don't see questions. I'm gonna assume we all completely understand.
Yes.
Okay. All right, I believe this is the last one. No, there's 2 more. All right. So now what we're going to be doing, because the first 3 that we did, we're saying, okay, if you have a parallelogram, then blah, 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 blah. They're saying if you have a parallelogram, then the first one was telling us then the opposite sides are congruent. The second proof was then the opposite angles are congruent. And the third one that we just did was if you have a parallelogram, then the diagonals bisect one another. Well, now let's read this theorem. Can I have a volunteer read this one? Somebody who's at home. Daniel, Alejandro, Samaj, Emily, somebody at home. Jalen.
I'm eating crab. I can't read right now.
Oh, come on, Daniel. Go for it. I want to hear you participating.
A quadrilateral is a
Just the theorem. Just the theorem, Daniel. Thank you.
If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram.
Awesome. So what is this the opposite of? What is this the opposite of? We've seen something similar, right? What was the first one we did? Was it this one? Yes. If a quadrilateral is a parallelogram, then the opposite sides are congruent. But now I have the opposite. I have if the sides are congruent, then it is a parallelogram. So what I have is if blank, then we have a parallelogram. So it's kind of doing it the opposite of what we just did. Okay, so now we're trying to prove that we do in fact have a parallelogram. So in this case, if I have a quadrilateral like this one, and the four sides, or each pair of sides is congruent to each other, then you can go and say, oh, this is a parallelogram. So let's see what this looks like as a proof. So it's telling us we know that the four sides are congruent, that each opposite side is congruent. Now what we're trying to prove is that we do have a parallelogram. And it's also telling us to draw DB. So you always kind of want to start with that step, draw DB. Because again, we know about triangles, we have theorems about triangles, so we want to use those theorems to find our answers. All right, starting with the first one. Well, they already did the first one, which is to draw DB. Then they're telling us to do, they're kind of mixing this up. They didn't put the given first. So given is somewhat, where is given? Which number am I putting given for? Good, Jalen. Step 3 is given, which is a little odd, but that's okay. All right, but step 2 is saying DB is congruent to DB. Why is that? DB is congruent to itself. Why? This is Tyrone's favorite one. I don't know why he's not in there giving us all the answers.
Janelle's knows it. She just hasn't said it.
Okay, say it, Janelle's. Good. There it is. Reflexive.
She would that, but she just doesn't want to type it in chat.
Janelle's, what are we going to do with you? Should Mrs. Santa Lopez take away your gift? Put you on the naughty list. You're getting coal for Christmas. Okay, reflexive. No coal, but what else are you going to heat up your fire with? You need the coal. Yeah, to make marshmallows. You can make a campfire. I was always like, why is that a bad thing? I want cold or never mind. Okay. You can grill, go out to the park and turn on one of those grills. Make some steak. Okay. All right. So here's what we have so far. Step number 4 is saying triangle ABD is congruent to triangle CDB. Why is that? I've seen that candy coal. I've never tried it, but it looks interesting. What are they, chocolate or something else? Well, at least it was yummy. Okay, why do I know that these triangles are congruent? How do I know? What do I already know?
Of SSS.
SSS. Good.
Guys, I shouldn't be doing this. I should be on my break. Never mind, I'm kidding.
You
No.
just can't help it. You can't help it, Perla.
I'm tired, miss. I'm trying to keep myself
I
awake.
know,
but
I
I'm serious
know.
about that cappuccino with 6 packets of sugar.
I know. Sometimes you just have those days, but we're almost there. You just got to push through. You got 3 days, less than 3 days till your break.
That's worse. I'm sad now because I will be able to wait. Let me think about what I'm gonna say. Next time I see you guys, I'm gonna say I haven't seen you guys since last year, and I don't want to say that. That's sad.
Oh, guys, I get it. I'm on break too. Don't worry. I know. I feel it. We all feel it. Trust me. All your teachers feel it. Or just getting through it together. All right. So now I know that the triangles are congruent. Next up, ABD is congruent to CDB. ABD is congruent to CDB. And ADB, wait, ADB is congruent. Okay. Why do I know that? How on earth?
Wait. Oh, alternate interior angles?
But do I know anything about parallel lines in this problem?
Oh.
You can't do alternate interior without parallel lines, and we don't have
Oh yeah.
parallel lines yet.
Parallelogram.
Yeah, so we don't have parallel lines quite yet, but what do we have? What do we know? Always go with what you know. What do we know? What do we know what have we written down? What have we proven? What was the previous step? We know SSS. So we know that the two triangles are congruent to each other. Good, Janelle's. We know they're congruent. We know the triangles are congruent. So how can I go and say that the corresponding angles are congruent? What allows me to say that?
I'm thinking something, but I think it's wrong. But
That's okay. What do you think?
I'm just gonna say it because sometimes I'm right when I think I'm wrong.
Go for it. What do you think it is?
Actually, never mind. Now I'm thinking it, but I was gonna say CPCTC or maybe Converse, but that's probably wrong. So never
Okay,
mind.
let's go back to when I talked about that. I think you might have been in the bathroom. Okay. Remember, we use CPCTC when? When you already know, when you know that two triangles are congruent, you use CPCTC to prove that two parts are congruent. Okay, so once you already know that two triangles are congruent, that's when you use CPCTC, which is exactly what we have here. We know that the triangles are congruent, so now I can use CPCTC.
Oh, so I was right.
Yeah, you are, definitely. Congruent parts of congruent triangles are congruent. Congruent parts of congruent triangles are congruent. Okay, Now I know that. And then next up, they're giving us that AB is parallel. Oh, that's not the parallel, sorry. AB is parallel to DC and DA is parallel to BC. What can I use for my reason? How do I justify?
Definition of a parallelogram. No, I'm lying, miss.
Well, you can use that in the last one. I'll give you that.
Yay.
I'll give you that. But how do I get there? What do I know? What do I know from the previous step?
Wait,
I know
isn't
that
it if both sides of a quadrilateral are congruent? No, never mind. You're supposed to prove that. Never mind.
Mhm. That's what we're trying to prove. But again, go to the previous step. What did we just prove?
See.
But what did I prove? That was my reason. What did I just prove?
That the triangles were Wait. I'm confusing myself. Never mind.
It's okay. What did anybody else? I'm not just asking Perla. What did I just prove in step 5? What did I just prove? That's not a hard question. Anyone can answer that. Really, guys? No one can use their eyes and read the words on the page? I'm just asking for someone to literally read off the page. What did I prove in step 5? Hello? Okay, thank you, Tyrone. So I know that these angles are congruent to each other. So how do I go from that to the next step? How do I know that because those angles are congruent, I have parallel lines? What type of angles are those by definition? My purple and my purple versus my green and my green. What type of angles are those to one another by definition?
Alternate interior angles?
They are alternate interior angles. Now, what I can use, that is exactly what they are. So I can use that in that next step. Since I have alternate interior angles, I know that those two lines must be parallel. But it's not going to be the alternate interior angles theorem. It's going to be the converse of the alternate interior angles theorem because I'm going the opposite way than from usual. Usually how it goes is you have parallel lines and you know that the alternate angles are congruent, right? When you have parallel lines, alternate interior angles are congruent. That is the normal alternate interior angle, this is long, theorem. But if I want to go the other way, if I have congruent angles and I want to prove that that means I have parallel lines, I'm going to use the converse of the alternate interior angles theorem. Just because I'm going backwards. Okay, so
This was possible. I didn't know this was possible.
But now you do. But now you do, don't you? That's what this was about. You didn't know this before. I'm teaching it. But we knew enough. We were able to get 90% of the way there without that. So, do I have any questions now? Okay, I have one more. It's going to be very similar. Our last theorem. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So again, this is going backwards. We don't know that it's a parallelogram yet, but we do know that these guys all bisect each other. So we're going to go backwards, same as this previous problem. Here we go. Given AE is congruent to CE and DE is congruent to BE. Given. Okay, next, AEB is congruent to CED. AEB is congruent to CEB. And AED is congruent to CEB. Why is that?
Vertical angles.
Okay. Now we have a whole step that we're missing, which might be tricky. But let's see what goes after that and then work backwards. So in step 4, they're saying that AB is congruent to CD. So AB is congruent to CD. So how do you think that they're able to prove that? If we don't, that's not given. We don't know yet that we have parallelograms. They skipped a very important step, I think. What very important step do you have to know first?
I was about to say that they're parallel, but no.
We don't know that yet. Think about what we have so far. What do we know so far?
We know that two sides and two angles are congruent. We could,
Is there something I can prove with the information I have so far? It's not reflexive, Tyrone, I'm sorry.
oh, SAS?
Okay, how do you know it? What do you know about SAS?
That it's side angle side.
And
oh, sorry.
which two triangles are you going to prove are congruent using SAS? Or which one to which one?
Wait.
Who is congruent to who?
Oh, DEA and wait, I have to read them to make sure I'm right. And CEB. DEA and CEB.
So there's DEA, I kind of pulled it out, and CEB.
Yeah.
Yeah, because I have SAS between both of these. Agreed?
Yes.
Okay, so that's good. So DAE is congruent to BEC using SAS. But that's not all we know. What else do we know? We know that those two are congruent, and what else? Anyone else? I don't want to hear, no offense, Perla. You get to take a break.
Yay.
How many mini triangles do I have? Only 2? Right, I have 4. I have 4 mini triangles. I know that I know that 2 of them are congruent. What about the other 2? The one on the top and the one on the bottom. Are those congruent? Those are also congruent for the same reason. We also have SAS between ABE and DEC. So we have SAS for both. So this is BAE. BAE is congruent to DEC. Okay. So now we know that the triangles are congruent. Next up, we have, okay, let me also just mark this down so this is easier to see. Okay, next up in the proof, they say that AB is congruent to DC. So AB is congruent to DC, or up here as well. I'll put it in both places. And AD is congruent to CB. Okay. How do I know? We don't know I haven't seen anything about parallel yet. I've proven that I have congruent triangles, so what always comes next? After you prove triangles are congruent, what can you do next? Once I know something about triangles, then I can prove, yeah, CPCTC. This is CPCTC. Because I know the triangles are congruent. Because of that, I know that all of the corresponding sides are congruent. Therefore, AD and BC are congruent, and then AB and DC are congruent. You guys are jumping way too many steps. Remember that these things have to make sense. They have to, you can't just say that they're parallel. Where in my proof did I say anything about being parallel? Nowhere. There's been no information about parallel lines, no information about angles that could help me to prove parallel lines anywhere in my proof. You can't just jump to conclusions. You have to go in a very, very careful step by step. Okay, now that I know that my sides are congruent, I can finally say that I have a parallelogram. And that is going to be using this theorem here that we just went over. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If, and I'm going to write it all down, you better be writing it down with me. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? There's our proof. That was it. That was the last one, I believe. Yeah. So we've did 5 proofs. Does anyone have any questions about how I got any step of those 5 proofs? It's very important that you guys know how to do this, and I trust that if you don't ask questions, it's because you are a genius and you understand 100%. Questions going once? Questions going twice? No questions. Okay. Here's a question I have for you. Is a square a parallelogram?
Yes,
Yes.
Yeah.
Why?
because
it's
it's
quadrilateral.
It's a quadrilateral.
right.
So that's not enough info. What else is true?
Not all quadrilaterals are parallelograms.
That's true. What has to be the criteria?
Um, yeah, basically it has to just be parallel, have two parallel sides.
It has 2 pairs of parallel sides. And then look at this. We know that if the opposite sides are equal, it's a parallelogram. What about a rectangle? Is a rectangle a parallelogram?
Yes,
Does it fit all the criteria?
yes,
Yes.
Is it a quadrilateral?
Yes.
Are the opposite sides congruent?
Yeah.
Are the opposite angles congruent?
Yeah.
Yes, it is a parallelogram. Okay, so that's that. I think we only have enough time. Yeah, we have 5 minutes, so let's just answer these questions. Let's see whether each statement will be always, sometimes, or never true. So, if quadrilateral RSTU is a parallelogram, then RS is congruent to ST. True, false? What do you guys think? Now, I don't see a picture in front of me, so y'all better be thinking of one or drawing one out. Will RS be congruent to ST?
No,
Why not?
because they're not opposite sides.
Good. If this is my parallelogram, R, S, T, U, they're claiming that RS is congruent to ST. But we already know that's not necessarily going to be the case. Now, is it completely impossible, or will it happen maybe sometimes?
It can be when it's a square.
Good. If you have a square, then yeah, we're good. So this is sometimes. Okay, next one. If a parallelogram has a 30-degree angle, then it also has a 150-degree angle.
We don't know that.
What do we know about the angles of a parallelogram?
The opposites are equal.
So let's pretend these two are both 30 degrees. What should they all add up to? Or that's the other
180.
way. Yeah, they should all add up. Or sorry, not to 180. Think again. Sorry.
Oh.
You're on the right track. 180 is a triangle. Triangle has 3 sides.
Oh yeah.
This has 4 sides. So it's not going to add up to 180, but it's going to add up to 360. Good, Janelle's. It has to add up to 360. So if 2 of them are 30, what should the other 2 be?
300.
They have to both add up to 300, so each of them has to be what?
150. Okay, yeah.
Yeah. Good, because it has to add up to 360. So yes.
I have a question.
Mm-hmm.
Can you do that in a square? No, right? Because that's gonna have to be.
No, but remember, this is already saying that the parallelogram has a 30-degree angle. So you're already assuming it has a 30-degree angle. So it's not talking about squares. It's just talking about any parallelogram with a 30-degree angle. Okay, next, if quadrilateral GHJK is a parallelogram, then GH is congruent to JK. True or false?
Yes.
Yeah, GH and JK must be congruent. In parallelogram ABCD, A is acute and C is obtuse.
Yeah, how would we know that? Like, unless you give us a value, but like, if you just look at it and you just want to say that A is acute and C is obtuse, like, you can't do that. You have no proof.
Okay, but you can, I mean, is A less than 90 degrees? You can tell, because what does a 90-degree angle look like?
A square.
Yeah.
Oh, the oops.
So it's saying A is acute and C is obtuse. Can that ever happen, that A is acute and C is obtuse?
No, because the opposite sides are supposed to be equal.
They're supposed to be equal, so this can never happen. So if one is acute, the other one has to be acute. If one is obtuse, the other one has to be obtuse, because they have to be the same. And finally, in parallelogram MNPQ, MNPQ, diagonals MP and NQ meet at R. Okay, let me draw this out really quick. We're almost there. Sorry, guys, that the bell rang. Okay. If they meet at R, MR is 7 and RP is 5. Can that ever happen? Can that ever happen? That one of them is 7 and the other one is 5? What do they have to be? Since we know that the two diagonals are bisecting one another, both halves of that have to be equal. They can't be different values. So that can never happen. All right, guys, that's it for today. I will see you guys. No homework. I'll see you guys tomorrow. Bye, everybody.
Bye.